All right, we're in week 7, and we're dealing with 7.1 Swyk 1. New unit, this is dealing with stuff called sequences and then eventually down the road series. But right now we're just dealing with sequences. Now, what is a sequence? A sequence is a list of numbers. I know, kind of weird. Some people think sequences are those little shiny things on girls' dresses, but different. It's different. Okay, so what's going on here? Since it's just a list of numbers, well, what you have in front of you is called an explicit formula. And why is it called an explicit formula? Well, it's called an explicit formula, and you can actually see another one down here in question 2, because you can plug numbers in and find terms instantly, or pretty much instantly. And it will make more sense when we get to another type of formula called a recursive formula. Recursive formulas have uses of finding like the first 5 terms, but after that they're not very useful. Explicit ones, you're very useful because you can use them for a lot of things. Anyway, so I want you to understand this notation. N represents the name of the term. So first term, second term, third term. There will be no 1.1th term. So there's not going to be any decimals or fractions in terms of the names of the terms. It's just first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, so on. But then A sub n represents the value of the term, okay? So it's kind of like an x and a y, and I want you to get that in your mind, that it's like an x and a y. It's not really anything different. It looks different, sure, but it's not really anything different. So this particular question says find the first 5 terms. I'm literally going to plug in 1, 2, 3, 4, and 5. You can see my work, what I did here, 5 times 1 minus 5, 5 times 2 minus 5, 5 times 3 minus 5, 5 times 4 minus 5, 5 times 5 minus 5. You can see that it's going up by 5. 0, 5, 10, 15, 20. Pretty straightforward. I could even ask you for the 90th term. Now, in a recursive formula, you wouldn't be able to do this, but literally, I could do 5 times 90 minus 5, which is 450, minus 5, which is 445, if I did that fast and quickly and accurately. Okay. That's just what a sequence is. So we have the name of the term, that's like your x, and those will be 1, 2, 3, 4, 5, and so forth. They always start with the first term, okay? We don't have the 0th term. We don't have, I mean, we can talk about a 0th term, but that's not really what you really want to do, okay? In my opinion. And there are no negative, I should say, the names of the terms cannot be negative. The values of the term, like the y values, the a sub n's, yes, those can be negative. That's a different question. All right, so question 2. Plug in a 1, 1 squared minus 1. Plug in a 2, 2 squared minus 1, 3 squared minus 1, 4 squared minus 1, 5 squared minus 1, 6 squared minus 1. That's all you're doing. These explicit formulas are pretty doggone easy, right? And you just type on a calculator and get your answer, and you move to the next part. So nothing too tremendously unusual about that. Okay, now let's get to the word recursive, right? What is a recursive formula? I said recursive formulas were good only for the first, 5 terms or so. You're not going to use a recursive pattern to find the 1,000th term, okay? Here's why, okay? You have to have a starting point. So we can see that the starting point here is -5. So you'll notice what I wrote right here. The first term, and I used a sub 1, that represents the first term, is -5, equals -5. So any one of these choices, and that is my starting point, and I'm going to kind of scroll up here. So any of these choices that don't start with a -5, man, they are out. They aren't even options, right? Because we have to start with a -5. That eliminated 4 of my choices. Okay, that's good. But then you have to have a rule to find the next term. So what are you going to do to find the very next term? Well, it looks like in this case, we are multiplying every time by -2. We'll find out later that that's called a geometric sequence. But all I want to do is say that the next term, and I use this symbol a sub n, and that's why I literally wrote next term, because this is just a rule to find the next one in the list. The next term is equal to, now look at this notation, a sub n minus 1. That means the previous term, right? If you had a long list of terms, like, first term, second term, and so forth, all the way down, eventually, somewhere in that list would be the nth term, right? We call it a sub n. So what would be the one before it? A sub n minus 1. Oops, doesn't look like a minus 1. And then the one after it, a sub n plus 1. And we could do, remember, the subscript just gives you the name of the term, which one it is in the list. The actual value of the term, that's what you have over here, okay? You can see the fifth term is -80. So recursive patterns, okay? So I start with -5, and according to this, it says to find the next term, I take the previous one and I multiply by -2. So that times -2 times -2. All I'm doing is taking the previous one and multiplying by -2, according to this pattern, which I think is, where are you at? Letter F, starting with -5 and then multiplying. The next term equals the previous term times -2. That's the one. So recursive ones are, I would never use a recursive one to find the 1000th term, okay? Who the heck wants to count all the way up through the one to the, you have to know the 999th term in order to figure out the 1000th one. Nobody wants to do that. That's why we like explicit ones. Okay, so this one is determine the formula, whether the formula is explicit or recursive. Well, if you take a look at it, look, it has the starting term, 3, and then it has a rule to find the next term. Well, that sounds like a recursive one to me. And you can see that it is multiplying the previous term by -2 and adding 3. Okay, so let me show you exactly how to use the formula. So we know we're starting with 3. According to the rule, you take -2 times the previous term, and then you add 3. So I took the previous term and I dropped it in here. So that's -2 times 3 is -6 plus 3. That makes a -3. Okay, well, guess what? This is now the previous term and gets dumped in here, right? Because you're always taking the previous one, multiplying by -2, and then adding 3. Well, when I did that, 6 plus 3 is 9. Then do it again. 9 times -2 is -18 plus 3. That's -15. Then take -15 times -2, which is 30, plus 3, which is 33. So recursive, you're always using the one before it to find the next one. Okay, definitely would not use it for the 1000th term. Question 5, it says find the next two terms in the sequence. Obviously, they are adding 5 every time, so that means 30 and 35. But the tougher part of this question is this. Which of the following formulas which of the following are formulas for the nth term? Select all that apply. Okay. Any term that in any one of these that involves the word recursive better have a first term, and it better have a rule to find the next term. And you notice that there's no little a sub n minus 1. Okay, so this is they basically mixed the word recursive with an explicit formula. Okay, they did the same thing down here on letter C. Well, letter G, you see they use the word explicit, but guess what? It's got a starting point and a rule to find. That's a recursive formula. Those don't go together. Here's another recursive formula. Okay, can't use the word explicit with that, so letter B's out. Now, we can see that they are multiplying. Let's see here. They're adding 5. We know that they're adding 5, so we have a first term of 5. And it says that the next term is equal to the previous term plus 5. That's a good recursive formula for that. But how do I change that into an explicit one? Well, you can see that when you plug in a 1, you're multiplying by 5, you get 5. When you plug in a 2, you get 10. When you plug in a 3, you get 15. So that's pointing us to this. If you were to come down here and look at that one, you would not get 5, 10, 15, 20, and so forth. Letter F is out. It's a recursive formula, that's true, but we're not multiplying by 5 every time. Otherwise, we would go 5, 25, 125, 625, and we're not doing that. So letter F is definitely out. So E and H are the only two that are good for this, and I'll meet you at the next Swyk.